Ladies and gentlemen, welcome to the channel of Beyond Consultancy, where we discuss all things operations excellence. My name is Herman Lemmens. In this keynote, we will explain the reorder point and safety stocks. This keynote is the third of a series. In the first two keynotes, we discussed the economic order quantity. In case you didn't see them, it may be a good idea to take a look before you continue with this one. In the remaining keynotes, we will discuss other order size optimization models. But let us continue with this keynote. Some of the key assumptions made in the economic order quantity model are that the orders are delivered on time, they are delivered in full and in one single batch. Furthermore, the demand takeout rate is constant and the order quantity is fixed. In this keynote, we will discuss some of the questions which arise when implementing. The first question deals with how do we ensure the timely replenishment? And this not only for one item, but how do we ensure this for all the items in the inventory? The way we go about is with something called the reorder point. It is the inventory level at which new orders are triggered. The reorder point is determined by the demand takeout rate D, for instance 100 units per day, times the order lead time, say 5 days. The reorder point would then become 100 times 5 or 500 units. Each time a withdrawal of a certain item is made, its on-hand inventory is checked. If this becomes less than the reorder point, a new order is triggered. If we do this for all the items, we may consider this way of working as a continuous inventory review system. The next question is, what happens if the demand takeout rate is lower than average? Will the next replenishment be correctly delayed so that we avoid too high inventories? From the diagram, we learn that the reorder point system indeed delays the next order placement. But looking at the details, we notice that at the moment of replenishment, the inventory was not yet zero. This is because we did not recalculate the reorder point to correspond with the lower takeout rate. It is a question of balance to either make the additional efforts to always be in the operational optimal point versus the simplicity of working with a fixed reorder point. Inversely, what happens if the takeout rate is higher than average? What if, at the same time, the order fulfillment lead time is also longer? How will we ensure the operational continuity? This is done by installing a safety stock. There are many approaches to the sizing of the safety stock. Assuming we need to provide the 100% service level, we need to have an idea about the worst case demand takeout rate and the worst case order lead time. Multiplying these gives us a worst case reorder point. Subtracting the first reorder point, which was derived from the average takeout and lead time, we get an idea about the maximum safety stock. Summarizing one thing and another, the average inventory size equals the fixed order quantity Q divided by 2 plus the safety stock. The optimal order quantity is not impacted by the size of the safety stock. And lastly, the safety stock can be based on more detailed statistical considerations, but also on matters of material strategy. The last one we will discuss in another keynote. Let us take a look at this event simulation, where the order quantity, the reorder point and the order lead time are fixed, but where the rate of demand changes over time. This brings us to the close of this keynote. Thank you for being here. I hope you found it interesting. Please leave your views in the comment section below, and I hope to see you again.